Okay. Thank you. Thank you for joining today's class. Okay. So now we are in fifth chapter. You know that we are discussing the distributed generation and power quality. Here two things here. The mainly two things here. Two things. First one, how these DGs are installed into the system. Second one, how these DGs will help to improve the power quality PQ. This is our concern because you are dealing with the power quality subject. So our concern is to how this DGs distributed generation will helpful to improve the power quality. So what are the problems while getting these DGs while you are installing in the systems, nothing but power system. So how this DG will helpful to improve the power quality. Then what are the problems will arise in the then what type of the problems will solve this DG, power quality problems will solve this DG. All the things we are discussing in this chapter. So what are the conflicts, what are the power quality issues it will solve the here now. So our concern is that how these DGs will help to improve the or will help to solve the power quality issues will arise in the power system. Okay, so now we are going to see here. So in the last class also we are discussing these three main types of the electrical interfaces systems. So the three things are synchronous machines or synchronous generators. You can also call it as a synchronous generators. So most of the generators we are using this one. So next one, asynchronous induction machines. That may be of generator or that may be of motor. So you know that the motor which rotates slightly more than the speed of the constant or some rated speed, we can consider as a generator. So next one is the third one is the most important one is the electronic power inverters, because nowadays the entire most of the things were installed on the solar. So while you are installed in the solar, so it requires this power inverters, electric power inverters or converters, whatever it may be. Small household also nowadays, very small households and all other things, they are installed with solar plates, solar cells. So on that time solar cells, they must have they must require this electric power inverters, because solars are DC. So but our operated power is AC, so that's why we need to convert this DC into the AC power. So that's why we require the power electronic power inverters or converters and all other things. Okay, then next one we are going to see it. Next one, so yes, yeah, sorry that for the interruption. Next one, now we can see this how this will act the systems, how these synchronous machines will add into the system. So how to add the systems, then how to use these systems. You know that synchronous machines or synchronous generators are mainly used, they are main common main machines in the power systems. They are main machines, they are main generators in the power systems. So you know that what is the difference between the DC and all other base load plants and all other plants? The plant which has generating less than 10 megawatt of the power, less than 10 megawatt, we can treat it as a DC distributed generation. So more than that one, we can read it as a some more than that power we are giving it to the grid. So this DC's power is also given to the grid, but in distributed grid you are connected this DC's. Okay, uh, just wait for the second, please. Allow me. Sorry for the disturbance. So now you can see this DC's. Last class we were already discussed all the things, but once again I will repeating all the things. So, so when you consider these synchronous missions, we are placing as a DC, that rating must be less than 10 megawatt. The generator capacity, the generating rating must be less than 10 megawatt. Under situation only you can consider that synchronous mission or that generating plants as a DC. But you know that most of the synchronous missions are have the large rating missions, so that's why most of the cases the synchronous missions we are not utilizing for DGs. Okay, so most of the cases DGs we are utilizing so this synchronous, where you can use the synchronous missions in DGs, nothing but diesel and generator set. You know that diesel and generator set, the synchronous machine we are using as a DC in most of the cases in diesel and the generator set. And second one is the gas turbine, combustion based or gas turbine based plants. We are using these synchronous generators as a DC machines. Okay, so but you know that nowadays this diesel and the generator sets are not using uh, only commercial purpose, like some apartments, some commercial buildings, shopping malls. On that purpose only, we are using this diesel and generator set to accommodate the interruptions caused by the power system. Okay, some but there are some problems while using this small machines to the disease and all other things. Okay, so we are already discussed in last class. Now we're going to see this asynchronous missions. Asynchronous missions, or you can also call it as a induction missions. You know that an induction motor operates or run rotating more than that speed, that rated speed, that synchronous speed, you can call it as the generator, synchronous generator. So where you can use this synchronous generator or induction motors, you know that most of the cases are asynchronous generators. We are also used in the um, wind turbines also. In wind turbines cases also can use this asynchronous induction generators type of the machines in the. So this is the second case. Then go for the third one, most important case. We are dealing with the most important one. This is the sorry. This is the most important one. Okay, yeah. Most important case is electric power inverters. You know that what is electric power inverters and all that things. A power inverters is convert and DC into the this is the DC into the AC. Now this is the AC because this is the transformer arrangement. So transformers is only connected to the AC systems. Okay, so where you can use this nowadays, most of the cases, most of the newspapers and news channels also are some news, we can see that so installation of the solar plants and other things, because these are the renewable energy sources. So how the solar plants are operated, they gain the energy from the sun. So that is freely available, that is renewable. So every day you get the sun energy. So that's why so solar plates and solar plants are very popular nowadays. At the same time, this wind turbines is also very popular. So the countries like India, Pakistan, and Sri Lanka, and the countries like China and other things. So the solar energy is very high because sunlighting is very. I mean, the day-to-day sunlighting is very. I mean, much time it is present in the system, because the average in our India, the average sunlight is nearly 6 to 7 hours time. Average sunlight is present in India. So that is a very sufficient time to generate the quality of the power by using the solar energy. But see here the main problem. by installing this solar energy plants. So the one thing is that generated power is DC. But here, uh, the grid or whatever it may be, our operated equipments, all the equipment, most of the equipments are the feeder power is AC power. So you must convert that DC generated power into the AC. Okay, you must convert the DC generated power into the AC. Okay, by using this inverter technology. But you remember that there is a one big issue while in this case. So what is the main problem by using these inverters? So when this conversion process, nothing but DC to AC conversion process. So we are using an electronic switches called IGBTs and other things. IGBTs. These are the IGBT. We are here in this problem in this diagram. They are using IGBT. This is the IGBT. So these are the electronic switches. So it can simply on and off and convert the some this DC lines to the this AC. This DC to the AC. This is the 10 voltage. Then voltage. This is the 10. So this uh, DC to the AC by on and off of these systems. This. So in this on and off case, will generate the harmonics. Harmonics. These are very severe in the power system. That causes very huge damage to the our consumer equipments. You know that what is the main problem while harmonics? The heating of the machines will increases. The heating because the frequency that will harmonics is mainly lies in the frequency. The frequency that observed from the system is increases. So this may causes the overheating of the machines. This may leads to the short circuit of the machines or burning of the machines. This is the main problem while harmonics because of the harmonics. So due to this switching actions and all other things, this will produces the harmonics. This will inject the harmonics into the system. So so thyristor based converters. Now these are the traditional thyristor based converters, but the technology is changing very rapidly, so that's why they generated that's why uh, they invented the methods operating that but the switches on and off technique methods that we can call it as the uh, PWM techniques. PWM techniques, we have different PWM techniques out there. Okay, what is PWM? Pulse width modulation techniques. PWM means a pulse width modulation techniques. We have different types of PWM techniques are there to operate this or to control or to whatever it may be to on and off of these switches, electronic switches or IGBTs. Different methods for I mean pulse width modulation techniques. The very famous pulse width modulation techniques. One of the pulse width modulation techniques is sinusoidal pulse width modulation techniques. Very famous method. So by using these techniques, we want to reduce the some harmonics. Even though by using this technique, PWM, there are small amount of harmonics that is injected into this AC cell. So to eliminate that frequencies also, we are using this filter LC filter, LC filter, LC filter, L and C filter to eliminate that harmonics also. But the installation cost while using this type of filter is very high. You know that when the rating of this inverter is increases, the rating of that filter is also increases. That may leads to the cost problem. Okay, that may leads to the increasing the cost of that inverter and all other things. So so that's why while we are using the solar energy to improve the power quality. Yes, solar energy is definitely will improve the power quality. But even though in that process you may get this some harmonics of the system. You know that electronic switch, what is the main problem by using these electronic devices in the power system? They may draw the current in non-linear. They may draw the current in non-linear form, just like this form, non-linear form. That may also leads to the harmonics. But these power electronic equipments are essential for converting these into AC. But nowadays, very famous companies like Delta and BHL and other companies are coming up with the very the latest technologies, PWM technologies, then artificial intelligence based technologies are also there to minimize this harmonics generated by these inverters. Okay, so now see here we are entering so our primary aim of this topic, our disease. So power quality issues. Okay, power quality issues. So now uh, what is our aim? So here disease, while we are installing disease, we will get the two problems. First one is installation, then second one is the how this disease will impact the power quality issues. So our topic is our intention is to know that how this disease will helpful or how this disease will affect the power quality problems that is produced in the system. Power system. Here in this, according to our syllabus, they can discuss about four types of power quality issues. First one is sustained interruptions, second one is voltage regulations, and third one is harmonics, and fourth one is voltage science. Now we can see this how our disease distributed generators that may be of diesel motor generators, diesel generator set, that may be of combustion, that may be of solar plant, that may be of wind turbines, or that may be of gas combined plants, that may be of battery cells, or whatever it may be, tidal energy, whatever it may be. DC is anything here. Here we are talking DC is anything here. That is less than 10 megawatt in the range, and the same time those are located near to the load locations. You can consider as a DC. Now we can see this how this disease will impact in the power quality issues. Here we are discussing only four things. So how this disease will impact the sustained interruptions, whether it will helpful to reduce the interruptions, or it may be leads to increase the interruptions. And second one, voltage regulation. Now you can see this how this disease will helpful to reduce the voltage regulation, or it may goes to increase the voltage regulation. How this disease will helpful to reduce the harmonics, and it may be leads to increase the harmonics. At the same time, disease also in this case. Okay, so interruptions. When the term is considered the interruptions, one thing you should remember is the reliability. So now in a power system, so many generators, you know that most of the generators are designed to back up the power. So most of the cases, backup power generators were using it as a diesel and the generator set. Diesel generator set. Most of the cases. So interruptions, you know that power interruptions. For example, in our college, we take the college, there is a power interruption is happened. So because of some external issues, so we can suddenly we can go and start the generator, diesel and the generator set to overcome this interruptions. So this disease has the potential to increase the number of interruptions in some cases. But why this disease we are using here? This disease will helpful to reduces the interruptions, but in some cases, these diseases have the potential. This has the capability to increase the interruptions also. But what is our primary aim here? Because this disease, what is our disease? Why you are using disease? To maintain the uninterrupted power. To reduces the uninterrupted power that is caused by the power system. So to reduce these interruptions, simply for example, you can take the or some a small commercial complex when power cut is happened. So they suddenly go to the diesel and the generator set. You can simply call it as a generator. They suddenly start the generator to eliminate these interruptions in the system. But in some cases, you know that we can see this. What are the cases to increase the interruptions? We are going to see this how this pages will also are there are some capability to increase the interruptions. Then second case is the voltage interruption. You know that what is voltage interruptions? Very well. What is voltage regulations? See that what is voltage regulation? A very simple answer. What is voltage regulation? So the sending end voltage, the difference between the sending end voltage and receiving end voltage. The sending end means a generator side. A receiving means a is like our customers and end users. The difference we can calculate it by using this voltage regulations. If more the voltage regulation, the losses is also very more. The less the voltage regulation, the percentage voltage regulation is very less. So we may treat it as the losses in the system is very less. Okay, so now see this how this DGs will helpful to reduce this voltage regulation in the power system. Okay, so at the same time, you know that harmonics, you know that because of using some power electronic converters. So DC, when you are talking about the DC, most of the cases we are taking considering to the solar plants also. The solar plants are DC, so we are converting DC to the AC. So we require the harmonics. Sorry, you require the power electronic converters. These power electronic converters may lead to increase in the harmonics in the system. So, but at the same time, this disease will also useful to reduce the hormones produced in the system. Then the main thing is here. Yeah, most of the cases, this disease are used to how to reduce this voltage size. So this is the important one. So now we can see this one by one how this disease will help to reduce the interruptions. Then what are the chances to reduces the voltage? Sorry, increases the interruptions in the system. All the things we are going to see. Now, now you know that many DC installations, especially in remember, especially in interruption cases, especially. So we are using diesel and generator set. Okay, so you are connecting this. In some cases, we are connecting this DCs to parallel to the backup, to back up the system. So whenever you are talking about these interruptions, the reliability plays an important. So what is the reliability? So whenever you are taking any system or any mission, how much reliable that mission to do that work. So whenever you are connecting the DC to the power system to reduces the interruptions, whenever there is a power cuts happen in the system, you are estimating that, or you are knowing that how this disease will capable to serving that load. See this point, how this disease must be capable to serving that load. So but in our households, you know that. So interruptions, diesel and generator set. So we are using large commercial areas and apartments and all other things. But in our households, also we are using some equipments, fuel cells, to reduce the interruptions in the system. So nowadays, most of the households they are installing rooftop solar cells. Yes, these are the rooftop solar cells to reduce the interruptions in the system. You know that when the power cut is happening in the system, so this DC is nothing but the solar cells will charge the batteries, so that the charge energy we are using. Whenever there is no interruptions in the system, and that time the solar cells will charge the batteries. So in this charging and discharging cases, we require an inverter, a thyristor based inverter. That may again leads to some power outage issues. But here we are talking about these interruptions, but the rooftops and all other things, where most of the cases they are supplying the not that much reliable inverters and all other things. This may are much storage capacity of the batteries and other things. So this may be leads to the reliability issues, that interruption issues. So for suppose there is a interruption, power interruption happened in the system because of this very not that much quality products we are using in the households. So and all other things that may not going to work properly. That may leads to the again interruptions. Okay, so that is the some of the reasons. There are very less reasons to improve the interruptions in the systems. Okay, next one is voltage regulation. So, so you know that DGs will improve the voltage regulations. Remember, and improving voltage regulations means here the percentage of voltage regulation gradually reduces. Okay, that is improving. Not we are treated as improving means here not increasing the voltage regulation. Increasing means here the amount of the voltage regulation is increasing. Improving in the voltage regulation means the percentage of for the voltage nothing but the primary side to the secondary side. Now this is the case. Source. This is the VS. We can consider as VS. We are receiving it. The gap, percentage gap. This gap is reduces. The amount of voltage we are sending descent to the descent is reduces by using this cases. So how this reduces? How this you know that a well planned, a well distributed system, the sending in voltage is always fast. So while the receiving in voltage is always changing because of some external factors. You know that some line losses, there are some power thefting and all other things. Receiving in voltage is very less. So that will lead to the voltage regulation problem. So where you can connect it this DGs. Now this DGs will connect it this side, receiving side. Remember this DGs will connect it receiving side. So this receiving in voltage we are going to improve. Not the sending end voltage we are going to improve. Remember, we are not going to increases the amount of voltage, sending in voltage. We are just improving, they are just increasing the amount of receiving in voltage by installing some DGs into the system. Because these DGs are installed near to the load locations. So nothing but VR side, nothing but and receiving side. Okay. This is the cases to improve this voltage regulation. But you are consider this point. You are taking this point. There are some small type of diseases. Suppose what is this point? A small disease is not powerful enough to regulate the voltage and will be dominated by the daily voltage changes on the regulator system. You know that you understand that point. Very simple. I will explain this point. So, for suppose a VS is there. Yes, this is the VR. This is a VR receiving in voltage. Now this side we are going to install the DC. These these are the customers, utility customers. So the smaller the size of the DC when compared to this line, what will happen? Why are DC is used to whenever there is a power cut happen in the system that may be used to reduces that interruptions. The primary motive of this stage is the same time second one is the voltage improvement. Now see this voltage improvement, these are the customers. You know that when the customer is on the system or when the customer is on the system, you don't know, you can't estimate that one. So uh, okay, you cannot estimate that one. So whether the size of the DC is very small when compared to the this load, you want to understand my point. And the size of this disease is small when compared to the load, this load. So there is no use of installing nothing, but there is, I'm not saying this, there is no use. So especially in voltage regulation point of view, there is no use, but some extent it is helpful to maintain the uninterrupted power in the power system. Okay, that is the point here. So now next one is the very critical thing is the harmonics. So please be wait for the second. Now see this harmonics. You know that harmonics very important in the power system. So especially so in DGs, so distributed generation where this harmonics is present in the system. So because of solar, the main thing is the solar. So for this solar, you know that, so solar is the DC. So we want to convert into the AC. For that purpose, you are using some this thyristor based systems. You know that we are already discussed here. Here this one, yes, this one. This we are going to install. So this may leads to the harmonics. You know that how that harmonics are produced into the system. Okay, so this DGs. So you know that because of this different types of these status these line commutated inverters, so some all other things will may leads to the harmonics in the system. So so that is one problem. So harmonics. Then second one is the another one is the some resonance into the system. Some reson so it may also leads to the increases in the resonant problems into the system. So, but in some cases, this problem is reduced because of using some capacitor in the uh, load side. You know that that capacitor. And other things. Okay. So the last one is the yes, the last one is the voltage side. So you see this how this uh, system, this DGs will increases the voltage side. You know that most of the power quality issues that arise in the power system is voltage sag. What is that one? Voltage sag. Voltage sag is the main issue. Yes, this voltage sag is the main issue. You know that what is voltage sag? The voltage, the magnitude of that voltage is in between the ranges. Uh, I mean, zero point 0.1 to the above zero point 0.1 to the below 0.9 range per unit range. We can treat it as a voltage sag. No, this sag. Yes, this we can treat it as a sag. You know that how this sags will present in the system. So this disease will help to reduce the sags. So how this is explained here, you can see this. So this is the utility system. Nothing but the main feeder. So main source VS, you can treat it as a VS. So in this one, in this feeder, we have again subdivided into the two categories. Some adjacent customers, and again you can by using them some transformers and other things, and step down and given it to the another customers. Here, so that loads near to that one, we are installing some DG, some DGs. So during this SAG case, so DC might act counter that SAG. Okay. So, but there is one problem in this DC also. Here in this case, the DC is larger than 1 megawatt will happen to require to its own service transfer. Therefore, it is somewhat difficulty to maintain voltage sags into the system. To why the reason? One simple reason is, so this sag range will appear in the power system is less than very short time, very short time. So in that short time, this DC sometimes may not operate to reduce this voltage sags. Okay, this is one of the problem in this case. Okay. Okay. Yes, thank you for joining. So next class we are going to see what are some conflicts while installing this DGs into the system. Okay, thank you.